Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We started a discussion with the chapter Definite Integrals. We started the basic integration, then we discussed how do we substitute upper limit and lower limit. Then also we learned the different applications of definite integrals, right? What all we learned? We started with limits, we started with the next few more problems of that. Today we are going to learn one more application, that is how do we find the area under the given curve. That is, for example, if I want to find some area, we are going to write it in the form of a function. Then by using the integration we can directly find the area of that. Integration is nothing but finding the summation for a discrete element. It is nothing but finding the area for a continuous function. Clear? Just have that particular difference in your mind. So let us find the area of few popular functions. What is the main thing? Let us find the area of a sine function first. So just tell me, how does a sine look? Sine function, that is sine 0, 0, right? Sine 45, sine 90, sine 180, and the next sine 90, 180, 270, and the next 360. Is it? Again it repeats. So this will be sine 90 is 1, sine 180 is 0, 270 is 1, 360 is again 0. And the amplitude is 1 here, and here it is minus 1. Till now we all know this is x and this is f of x. So how do we find this area under this curve? How can we do this? That is, first let us separate it. That is nothing but finding area from 0 to 2 pi sine x dx. Yes or no? Fine. So if you observe here, whatever the area is here, the same area will be here. So can I write whole 0 to 2 pi as double of 0 to pi? Yes. Can we write? Or else let us write it separately and do 0 to pi once and pi to 2 pi once. Yes, from 0 to pi and then again pi to 2 pi. Clear? And one more thing, if you observe, here 0 to pi it is in the positive phase, and here pi to 2 pi it is in the negative place. So we have to write minus here. That is one more thing you have to remember. This is in the negative plane, that's why I have written minus. Remember that. Fine. Next. Now directly integrate. Sine ka integration is minus cos x 0 to pi. Here also minus cos x 0 pi to 2 pi. Right. Now apply this everything in a proper manner. Minus of cos pi minus cos 0. Is it? Again minus of cos 2 pi minus cos pi. Is it right? What's the value of cos pi? Cos pi is minus 1, cos 0 is 1. Is it right? Cos 2 pi is 1, cos pi is minus 1. Yes or no? Is it clear? Cos pi is minus 1, cos 0 is 1. Cos 2 pi is 1, cos pi is again minus 1. So it will be minus of minus 1. Now if you observe, minus into minus, minus 1 is minus 2. Here minus 2. So tell me, plus 2, minus 2 minus plus 2. This is 4 square units. Is it right? What if you don't write this? That is units. Half of your marks will be cancelled. So don't forget to write the units of any area. Is it clear? Fine. This is how we are going to find the area under the given curve. What is that? We have to keep it in our mind. First thing, we have to check the limits, right? Second thing, you have to check whether it is in the forward plane, positive plane, or in the negative plane. That is one more thing you have to remember. Is it clear? You do understand? Similarly, we can also find for cos also. How do we find for cos? 0 to 90, 180, 270 and 360. You are going to find the area of this particular shade. Clear? So, let us integrate cos x as first 0 to pi by 2 cos x, right, and the next pi by 2 to 3 pi by 2 cos x, and then again 3 pi by 2 to 2 pi cos x. Is it? Yes or no? Hope you got a basic idea. How did we write this cos? You know that, right? Cos 0 is 1, cos 90 is 0, cos 180 minus 1, cos 270 is 0, cos 360 is again 1. Again it repeats. Clear? Now here cos 90 to 270 is negative. Now just substituting and simplifying. Cos x ka integration sin x 0 to pi by 2. Here also sin x pi by 2 to 3 pi by 2. Here sin x 3 pi by 2 to 2 pi. Now just tell me sin pi by 2 is 1. However, this is 0. Sin 3 pi by 2 which is 270. Sin 270 is sin of 180 plus theta, which is in the third quadrant, that will be minus 1. Okay. Here it is minus 1. Pi by 2 it is again 1 plus sin 2 pi is 0, sin 3 pi by 2 is minus 1. Now if you observe 1 minus this will become minus 2 plus 2, here minus 2 minus plus, again the area is same here, right? The area under cos x, sin x are always same, but there will be a kind of phase difference. You have to remember that term. That is a physical term, but as of now I am telling there is a slight difference. Clear? But the area under two curves, that is sine and cos, is always same. So how do you identify is their time period, that is their repeating time should be same, that is the first thing, and the amplitude should be same. Okay, so we can tell that the area under both the curves will be always same. Is it right? Did you understand? These are the basic things which we are going to discuss. So how do we find the area under the curve? First we have to plot the area, right? Second we have to locate the limits, that is from where to where it is, and you have to locate the amplitude also. Finally you have to integrate and simplify. Clear? And don't forget to mention this plane. If it is in the negative plane, it is mandatory that you have to mention the negative sign. Clear? Shall we start doing problems? Let's do. Look at the question here. He is telling that find the area bounded by y equal to x square, the x axis and the lines x equal to minus 1 and 2. First thing you have to do is first draw the graph. What is the curve for y equal to x square? If you don't know, try to draw the graph, okay, by pointing each and every point. Y equal to x square, okay. What is for different values of x? Let me take for different values of x, I will get different values of y. 0, 1, 2, minus 1, minus 2. Y is 0, 1, 4, 1, 4, because if I substitute 0 here, I will get 0. 1 square is 1, 2 square is 4, like that. So let me mark 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. X, y, here 1, 2, 3, 4. Now if I observe 0, 1, 2, 4. So here minus 1 and here it is 2, 4. Is it right? So x-axis is this, and the lines x equal to minus 1 and x equal to 2, x equal to minus 1. So this will be here. and x equal to 2 will be somewhere here, right? Yes or no? From minus 1 to 2 with x axis and with parabola. He gave 4 conditions, that is this to this. Right, did we cover everything or not? Just check it here. This is the parabola, this is x axis, this is x equal to minus 1, this is x equal to 2. So, the direct area is nothing but integral of this parabola from minus 1 to 2. Yes or no? What is the equation of x axis if you tell me? Y equal to 0. So, in order to integrate that, the limits are x, integral minus 1 to 2 f of first function, that is what is y here? This is x square minus what is y here? 0 dx, right? We are coming from the upside, that is upper curve minus lower curve. What is upper curve? That is nothing but parabola, right? Once again see here, if this is a graph, if I have this is one function and this is one more function, if I want to find the area in between, this is f1 and this is f2, so I have to integrate from f1 minus f2. Is it clear? From which range to which range? This is x1 and this is x2. Clear? That is how we are going to write for all. This is a simple generalized thing that is not fixed or which is fixed for a particular shape or like that. It varies from shape to shape. So, let us integrate this. X square ka integration is x cube by 3 from minus 1 to 2. So, this will be 2 cube by 3 minus 1 cube by 3. So, this is 8 by 3 minus 1 ka cube is minus 1. So, this is 9 by 3, that is 3 square units. Clear? But the thing is, we have to know that where to substitute which thing. Next, see here, y equal to x cube plus 3. So, again let us take the different values of x and let us find the values of y. Let me substitute it from minus 2, minus 1, 0, 1 and 2. Minus 2 cube is minus 8 plus 3. Is it right? Next, minus 1 cube is minus 1 plus 3. 0 plus 3, 1 plus 3, 8 plus 3. Clear? Once again, you have to check correctly. Minus 2 ka cube is minus 8 plus 3 is minus 5. So, if I draw the curve under this, I will get it as 1, 2, 3, minus 1, minus 2, minus 3, and here it is 1, 2, 3, 4 and so on. Let it be. Here for minus 2 it is somewhere minus 5, for minus 1 it is plus 2, for 0 it is 3, for 1 it is 4. This is the curve. Yes or no? For minus 2 it is somewhere minus 5 here, right? So, this is the curve. Obviously, you will get x cube is somewhere like this, a sharp integral symbol. Next, y equal to 0 is again x axis. You know that. X equal to minus 1 to 2. Here x is minus 1 and here x is somewhere 2. Clear? Now, we are going to find the area under this curve. How do we find? The same issue. Area is integral minus 1 to 2. This is first f of x, that is x cube plus 3, and this is second f of x, which is 0. Right? So, let us integrate it directly. I will get it as x power 4 by 4 plus 3x from minus 1 to 2. 2 power 4 is 16 by 4 plus 3 2s are 6 minus 1 power 4 is 1 by 4, here minus 3. So, 4 1s are 4 4s are 6 plus 4 is 10 minus 1 minus 4 3s are 12 by 4, right. So, 40 plus 13 by 4, that is 53 by 4 square units. Clear? Check again. Here it is x power 4 by 4 plus 3x. If I substitute 2 power 4 is 16, 16 by 4 plus 3 2s are 6 minus, let us substitute minus 1. Minus 1 ka power 4 is plus 1 by 4. Here minus 3. 4 plus 6 is 10 and here LCM is 4. 4 3s are 12. That is 1 minus 12. That is minus 11, minus to minus plus 11, 40 plus 11, that is 51 by 4 square units. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. Till now whatever we did, one was a function and remaining all other things were constants. Here they gave two different functions. They are asking us to find the area bounded by y equal to x square and y equal to 2x. Just draw the graphs for different values of x. Let me say it as y1 and y2. Okay, for our simplicity, minus 2, minus 1, 0, 1, 2. Okay, till where you want to substitute, it's up to you, but these are the basic minimum values. After that, according to the requirement, if the two curves are not touching, in that case we will take more numbers. Okay, minus 2 ka square is 4, minus 1 ka square is 1, 0 square is 0, 1 and 4. What about this? Minus 4, minus 2, next 0 into 2 is 0, 1 into 2 is 2, 2 2s is 4. Is it clear? So, directly we can plot it. So, let me plot it here itself. This is x axis 0, 1, 2, 3, minus 1, minus 2, minus 3 and here 1, 2, 3, 4. Okay. Now for this, for minus 2 it is plus 4 and here it is minus 1, minus 2, minus 3 and here it is minus 4. Okay, let me plot it for y1. 4 minus 1 ka is 1, 1 ka is 1, 2 ka 4. You will get a parabola like this. This is my y1, right? Next for this minus 2 and minus 4 and the next minus 1 comma minus 2, 0 comma 0, 1 comma 2, 2 comma 4. So this will be our straight line. Okay, this will be our straight line. This is y2. Okay, now we have to find the area under this curve. So how do we find? Either you have to take the x limits, right, from where to where it is, okay, or else you have to take y limits. So how do we find is, you have to find area under the curve as integral x1 to x2 as y2 minus y1 into dx, right, or else you can take the limits of y. You can take from this point to this point and you can find area. Let us do it in the two ways. First let us find it with respect to x, that is from 0 to 2. Let us do y subtraction, that is let us subtract the upper wala is y2 and the below is y1. So let us substitute integral 0 to 2, 0 to 2. What is y2? Let's say 2x. What is y1? Let's say x square, right? Don't get confused. For your awesome clarity, let us do it in the one more method also. 2x is x square ka integration is x cube by 3 from 0 to 2. 2 square is 4, 2 cube is 8 by 3 minus 0 minus 0 however. So 4 3s are 12, 12 minus 8 is 4 by 3 square units. Did you understand? Is it not easy to solve? Yes, right. Now instead of y2 minus y1, let us take it as x2 minus x1. So how do we get? See here. Here I will write x1 as root y. Can I write it? Here can I x2 as y by 2. Clear? Now the area will be integral y1 to y2. Just check here. From this side we have to take. Okay, from positive to negative. From the limits are 0 to 4. Here the y1 is first and y2 is next. So this way, I mean x1 is first and x2 is next. Clear? We have to come from this side. Now what is y1 here? From 0 to 4 root y minus y by 2 dx. Okay. Now what is the integral of root y? Y power 3 by 2 by 3 by 2 minus what is integral of y? Y square by 2 from 0 to 4. Okay. Now let us just substitute it. What do we get? 2 by 3, 4 power 3 by 2 minus half 4 square by 2. However, if we substitute 0, we will get the answer 0. Now just tell me 4 power 3 by 2. What is the answer for that? Tell me. Before that, 4 square, 1 4 and 2 2's will get cancelled. I will get it as minus 4. Here 4 can be written as 2 square. Yes. So let us simplify that also. 2 square, 2 2 will get cancelled. I will guess 2 power 3 plus 2. That is directly 4 by 3 minus 4 I will get. So just see here, 2 power 3 into 1, that is 2 power 4, which is 16 by 3. So if I take LCM as 3, I will get 16 minus 12. Directly answer is 4 by 3 square units. Is it right? If you understand this simplification, you can understand by solving. But is it okay? Are we getting the same answer? So remember, how do we solve a given combination of two curves? Clear? Is it okay? Fine. What all we discussed today? We mainly discussed how do we find the area under a given term, a given curve by using integration method. Clear? Fine. In the next session, we will have more difficult combination of curves. Clear? Fine. This is for today. Let us meet in the next session with the more problems of areas under the curves. Thank you.